Okay, we're going to do the Truss Calculations. Try to record these for you. So we're going to be working through this note sheet and working through our steps 1 through 9. I will say I have already done the reaction forces for the Truss Calculations. The reaction forces, I think this probably could go up a little bit. We already have sketches made for us, so that makes it a little bit nicer. We're going to work through that. So we look at this one. We're using the PLTW, the general PLTW one that's inside of there, the example and the actual assignment. But this is our distances that we had, and then we had our forces of 1,000, 250, and 500. I went ahead and just so we can get used to them and labeled them: force at D, force at B, force at E, and then went back and put in the reaction forces. So the reaction forces, we realize this being a pin, it's going to be pinned, so it's not going to be able to move up and down. It's not going to be moved back and forth, and so those forces, when they come here, are going to have to react to that at that pin. So we end up with a reaction force at X in the X direction. Sorry, reaction force at A in the X direction, reaction force at A in the Y direction, because it's a pin. And we come over here, and this is a roller, so it's got one reaction force. It's just sitting on top of the roller, so it's just got a reaction force to hold that side up, where it's sitting on top of the roller, so we have a reaction force at C in the Y direction. I went ahead and put this down here. Sometimes you may see people write RF, reaction force, at C in the Y direction. I am perfectly fine with you writing it that way as well, because that may help you out with realizing that we've got a force here, and this is still a force, but it's a reaction force at C. I just start seeing too many letters, and so I go ahead and leave that off, but that is perfectly fine. You just notice that I don't do that very often. Occasionally I'll put that on there. But if that helps you to remember that that actually is a force, reaction force, when we say it that way, it's perfectly fine to write it that way. Okay, so we need to do static determinancy. We remember the equation for static determinancy. Static determinancy is 2 times the number of joints equals the number of members plus the reaction forces. So if we look at this and we count our number of joints, we have 1, 2, 3, 4, 5 joints. So we're going to do 2 times 5 equals number of members. Each place we have a joint is going to cause it to be a different member. So 1, 2, 3, 4, 5, 6, 7 members. So we're 7 members plus number of reaction forces. Why keep moving that? We have 1 reaction force, 2, 3. There's our reaction forces, so we have 3 reaction forces. So plus 3. So we end up with 10 equals 10, which means we can continue to solve this and continue to work through it. So what we want to do next on our next step is find the angles using the given lengths. So we're going to take this and use our lengths to solve these triangles for angles that we can get out of this. We think about this, if we extended this down and made a triangle out of it, we would have a right triangle here with an opposite of this angle being 3 and an adjacent of this angle being 3. So when we start to work on these angles, let's go ahead and write down all the angles we're going to need to work with. We really want this one, we want this one. We want to do the same thing on the opposite side of the bridge, this side, and we want to go this. So we want these 2 angles. We are also going to want these 2 angles off from this piece here. And then with that, if we need anything else, we could actually solve it, but we're probably not going to need any more than that. But we are going to be acting like there's a straight line there. We're going to be acting like there's a little line here that allows us to deal with those angles. And if we have our other sheet in front of us, you notice that's what they did here. So if we would like to, we can go back and look at these sides and say, we know that the height of this was 3, the length down here was 3, we know this length was 2. Do realize that this is not to scale. This length is shorter than this length physically on this drawing, but they gave us the distances. So this is a model to help us represent. It isn't to scale. So this section is going to be 2. This section over here we know was 2, 3 tall here, we know that's 3 tall, and we also know that this was 3. That should help us out with dealing directly with the angles. So what angles do we want? We want angle D Remember, when we're labeling angles, we use the vertex as the middle letter, D, A, B. We could also call this DAC, but that would be an awful long way to go, and it just cause extra confusion. So we try to go with the closest letter that we have. This angle over here, DBA. Then we're going to go to the other side, ECB. Let's go ECB. Angle EBC. EBC. Then we're going to go to ADB. We're going to go ahead and get this angle across here. BEC, get this angle across here. And then we're going to work on that middle triangle, work our way back to that middle triangle. BDE, BDE, and angle DEB. Those should be enough to get us everything we need. I really didn't need to put all those equals in there, but I did it anyway. Okay, so now, what are we going to do? We're looking at this angle right here. So I have the opposite, I have the adjacent. Opposite and adjacent, if we look back at our setup over here, opposite and adjacent should be telling us that we're going to be dealing with tangent. Do realize for some reason left out an equal. Should have wrote this as tangent of the angle equals. So unfortunately didn't get that fixed in the edit, so it's showing up incorrectly on there. Okay, but we're going to be dealing with tangent. Opposite over adjacent. So we're going to use the inverse tangent, and we're going to do the inverse tangent of 3 over 3, which is going to equal the inverse tangent of, we know that's going to be 1. So, and if you're looking at this, an isosceles triangle, these two sides are the same, this is a 90-degree angle, which pretty quickly should tell you that should be 45 and that should be 45. So it's a pretty quick, easy way to tell what's going on with these two. So, and if you solve it out, it does come out to be a 45-degree angle. Okay, so if we continue, what's our next one? DBA. So now we have 3 over 2. And if we put that in to our calculator, should already had this pulled up. And I'm going to do the inverse to inverse these on my phone. So I'm going to go 3 divided by 2. And I think I put that in the wrong order on my calculator. I'll have to do tangent. 3 divided by 2. And we're going to go 56.31. We don't want to round until the end as much as possible. So yes, I'm rounding that off a little bit, but we'd like to keep that as rounding until as close to the end as possible. Okay, so angle ECB. If we look at this, it's 3 over 3 again, so it's similar situation so to what we had up here. So we should be able to find that. Tangent, inverse tangent of 3 over 3. So 45 again. And if we notice, this is basically mirror image. This side and this side, they're mirror images of each other. So we already know, again, we can figure out what this angle is because it should be the same as this one. We're not dealing with the forces yet, but everything else about this is mirrored about the center point, so it's going to come up with the same angles on each side. So again, we end up with the inverse tangent of 3 over 2. So we end up with 56.31 degrees. Okay, so angle. Now, at this point, angle ADB, we know we have this angle and we have this angle. and I should start writing them in. So angle A was 45. Angle DBA was 56.31. And so at this point we want to figure out what this, so we figured out those. We want to figure out what this whole angle is. So if we wanted to calculate that, what we need to do is we need to say, okay, these three angles should equal 180 degrees. So those interior angles. So if we add these two together and subtract them from 180, that should give us what our number is. So we're going to take 180 minus 45 plus 56.31. $78.69. So this one should be 78.6 degrees. And if we work our way to the other side, we should be able to fill these other ones in as well. So we have angle EBC, and 56.31, and we know this one was 45 because it's the same as the other side, and we just went through and calculated those. So we can go ahead and put this one in, even though we didn't even solve for angle BEC. Oh, there it is. Let's go ahead and do the same thing. Remember, it's the same thing as the other side. Okay, so now we're going to work our way into these inside interior angles. So BDE. So we need to work on BDE. So we're looking at, once again, we're looking at this angle. There are a couple of things we could do here. One, first, right off the bat, we should look at this and say, these two, because these are the same distance here and here, this is a line bisecting a parallel line, so alternate interior angles should be the same. So we know a checkpoint for this is to know that this 56.31 should still be 56.31 up here, so it should stay the same. So if we take 56.31, how are we going to find that? Well, if we look at this, there's the opposite, there's our adjacent, so it's 3/2. So we're inverse tangent of 3/2 again. And if we look up here, we already solved it, it's 56.31. So once again, we know that that is what that's going to be. And if we look at this, this is the same setup, so we should have the same thing over here. So same alternate interior angle, so we know that that should be the case. So with still tangent, inverse tangent of 3/2, and once again 56.31. Okay, so now we've got to learn. We've solved for our angles, the angles that we should need. If we need to, we could always go back and solve for this one. We can solve for part of this one. However we need to do that, we can work that out. But at this point, we're going to stop this video there, and we're going to move into our next part, which was 3. We said we can go ahead and do that. 3 we said was we needed to deal with sketching the truss with reaction forces, and we have sketched our truss with reaction forces here. We have all the forces, we have all the reaction forces, so we have already done that on the diagram. So basically we were looking for anywhere we have a pin, we were looking for this. Anywhere we have a roller, we're looking for this. So at our pin and at our roller. So we did a reaction force at A in the X direction, a reaction force at A in the Y direction, and we did a reaction force at C in the Y direction. And so that's what we did. Okay, we're going to stop this one here and pick up in the next. Okay, we're going to continue with step 4. So step 4 is sum the moments to find reaction force. So we're not going to be dealing, so we're looking at no member forces. So if we come down here, we're going to do using our equation, summing our moments. So number 4, we want to sum our reaction forces. I like to do this in table format. So I'm just going to remind myself of what I'm doing. So I'm going to do the sum of my moment should equal 0. So when I like to do this table format, I like to set things up and say, what are my moments in the clockwise direction? What are my moments in the counterclockwise direction? So I'm going to go ahead and set up a table, and I'm going to say, my sum of my moments, I end up with do clockwise, counterclockwise. And just remember, a moment equals a force times the distance. So I like to write out all moments and figure out what all they are first, and then work my way to solving for them. So we're going to need to have our forces that we had worked with earlier and our distances. So at this point, we know we have to look at where our forces are at. We have a force here, a force here, a force here, and a force here. Reaction force over here, but still a force. We have reaction forces over here, but remember, this is our pivot point, so this is our 0 point. If we were to try to calculate a moment with this, we have a force, and a force, but they are at 0 distance, so that means we're not going to have a moment. 0 times force is still going to equal 0, so we're not going to have a moment there, so we don't deal with those. So the first one we're going to deal with is the moment at D. And it is coming down, which is going to cause this to rotate in a clockwise direction. So we want to make sure and put that on our clockwise side. So I'm going to say the moment, we're going to have a moment at D. At B, we have another moment, yet again. This is going to cause a rotation in the clockwise direction. So that's going to be clockwise, and we said clockwise is also negative. I'd like to go ahead and put that on here, just to kind of keep track of it and get that in our head. So we're going to go in clockwise direction, so we have our moment at B. I'm going to go ahead and set equal because we're going to need to solve those. And we have E, same thing, so it's going to be going in a clockwise direction. And then we have our reaction force. Notice it is going up. It's going to, we looked at this, it's going to go in the counterclockwise direction. So that's going to be a positive. So we have our moment at our reaction force at C. So it's actually a moment at C. I'm just going ahead and keeping track that it's a reaction force moment there. So let's solve for them. So how far is it from this point out to where the D force is going to be? It's 3 inches. So that's going to be our force, 1,000 times 3. Should have left myself a little more room. Okay, moment at B. It is 3 plus 2. It's 5 times 250. So 250 is my force times 5 inches. I am okay. 750 And then our moment at E was 3 plus 2 is 5 plus 2 is 7 times my 500. So it's 500 times 7. So that equals 3,500. So if we total all these up, we end up with 6,500, 7,250. Times 5 would be helpful. If I would multiply that correctly, sorry. 2 times 3 rather than that. So that's 1250. So that's going to give me a different number. So we're going to come up with 7750. Okay. So that means on this side has to also be 7750. So if we look at this and we work this, we're looking at this, make sure you don't have any other forces that are in the counterclockwise direction. If we double check our diagram, we do not. So that means that if this is all that's the only force that's there, this has to be what our reaction force equals. So that's going to equal our reaction force. So reaction force at C is going to have to be 7750 in the positive direction. Now, if we want to solve that out, we want to actually find out what is, that's our moment, sorry, I said reaction force, that is our moment. We need to solve for our reaction force. So if our moment equals 7750, that should equal our force at C times our distance to C. And we know that we need to solve for our force, which means we're going to have to divide both sides by our distance to C. So force at C must equal 7750 divided by our distance. 3 plus 2 is 5 plus 2 is 7 plus 3 is 10. So divided by 10. So our force must equal 775, force at C. And that's going to be pound force. If we left these and we said these were in inches, I don't remember in the instructions if it had told you what those units actually were. We were making a model scale. This probably would be more likely to be in feet. So I didn't put any units down here, so probably should have apologized for that. Left these out that way and just said we'll assume they're in feet. So that would have been over here, would have been pound force feet. Would be more logical for the definitely for the forces that we've got on this. Like a small walking bridge, basically. Okay, so we figured those out. So we've got those forces. The next thing we want to do is we want to go back and we want to solve for our other reaction forces. So we want to figure out what these other reaction forces would be. So let's look at our steps again, make sure that we're getting everything solved. So we were down to sum the moments to find all reaction forces. So counterclockwise, we talked about that. We talked about our, go back to our right hand rule. We talk about curling our right hand up, and we talk about the direction of spin and where it's pointing. That can help us determine which way is positive, which way is negative also. I like the table. I don't have to worry about that quite as much. Okay. So now let's go back and we'll find our forces, deal with some of our forces. So we're going to go on to step 5, sum the forces to find the remaining reaction forces. So we want to sum our forces. What do we want? We want the sum of the forces in the x direction. We know those are going to be equal to 0. Sum of the forces in the y direction going to be equal to 0. And so we're going to work with that. So what do we have so far? I'm going to start with the sum of the forces in the y direction. And I'm going to do the same thing. I'm going to do a table with this. So what are we going to deal with? When we're dealing with y, we're dealing with our forces in the y direction, we're going to deal with an up and a down. So we want to find all our forces that are in the up direction, all our forces in the down direction. So what we're going to deal with is we're going to deal with our forces in the up direction, which would be a plus, and our down direction, which would be a minus. So what are all our forces in the up direction? We have a reaction force at A in the y direction. Do we have any more ups? There's a reaction force at C in the y direction. And now what are our downs? We have a down, a down, a down, so we have those. So we have a force at D, we have a force at B. Sorry, I'm going to slide that off the page. Let's move it over to this side. We have a force at C. And so now, sorry, that's an E. We have a reaction force at C. So now we need to look at what all those are. So we said our reaction force at C was equal to 775. We just calculated that right here. We have a force at D was equal to 1,000. Force at B was equal to 250. Force at E was equal to 500. So if we total those up, we end up with 1750. So that means this other side we also have to have 1750. So we don't know what the reaction force at A is at this point, so we need to figure that out. So at this point, what we're looking for is we have 775 and we have an unknown. We know that our total has to be 1750. So what do we know has to happen? We have to take our total, 1750, minus our 775. And that should give us our reaction force at A in the y direction. So we end up with 975. So our reaction force at A in the y direction is 975. And these forces were in, just to keep up, pound force. Okay, we need to work with what are some of our forces in the x direction. Some of our forces in the x direction, what do we have? We're going to be dealing with left and right. So I apologize, I flipped things around and keep flipping my positive and my negative columns. It would be best for my purposes if I would keep those straight for you, but it really doesn't matter which column you're putting them in. I went ahead and did this left as being the left side, right as being the right, and so left it that way, but we've got it that way. So now if we look at this, do we have any forces that are pointing in the left direction? We don't. All these are up and down. The only force we've got is this one. That's in the right direction. We have a reaction force at A in the x direction, and we know we have no other forces. So there's no other forces pushing on that, so that has to be 0. So if we look, there's 0 here, that means this side has to be 0. So there's no forces pushing against it, so our reaction force at A in the x direction has to be also equal to 0. And I'm going to stop there. Okay, so now we're ready to work our way into steps 6 and 7, and we're basically going to be working that over and over again. We work our way all the way across the truss bridge. So we're going to be looking at individual angles at a time. So we're going to look at an angle like this. We're going to work over here because these are going to be very similar. They are not going to be the same. Yes, we have a mirror image bridge, but also realize we have a 1,000-pound force here, 500-pound force here, and a 250 in the middle, which isn't going to be as big a deal for that. But these are not the same forces. Yes, if we put force on both sides, we should be able to work through that a little bit easier, but we want to see what happens when we put a different force on an equally loaded, equal, side mirror image bridge. We could go back and change these numbers later and see what kind of things happen with that. But at this point, we're just going to be noticing that we've loaded this bridge heavier on this side, with more force, I shouldn't say heavier, with more force on this side than what we've loaded with the force on this side. So we're going to break it up, and we're going to be drawing just this angle. So we're going to start with just this angle and work our way along. Then we'll work our way over here. And so that's what it says, what we're basically looking at here. Obtain force diagrams for each joint, assume tension for each member force. Tension allows us to stay positive to begin with. Or, again, they say use logic. We'll work our way through trying to figure out what they're talking about with that. You want to look at what they say here. I know this is a little bit difficult to look at. I should have highlighted that a little bit more. On here, they're showing this way with the number in between, and they show if it's in tension, we set it this way. So, depending upon what you're looking at, I believe the simulation, different simulations may show it a little bit differently. But always look for whether they're showing compression or tension. Sometimes they'll use a C and they'll use a T to help delineate and make sure that you're straight on which one's tension, which one's compression. And so that's something to keep in mind as we're working through this, and they talk about the logic aspect. Double check things to make sure it's working out well. Okay, so what are we going to do? We're going to use some of those angles that we've already been working with and looking at. So we want to go back to our angles and forces. And so we're going to start with angle DAB. And we're going to start with our force angles and forces that we have from there. So that is, we're working basically at step 6. And what we would like to do is we're going to work through all of these angles as we're working. But I want to look at this and say, here's my angle. Hopefully I left myself enough room over to the side. We know that this angle was a 45-degree angle. So there's a couple of ways to look at this. I could look at right over here. I am not going all the way over to point B. Point B would be over here farther. I'm just looking at this angle, so I'm dealing with forces. I do not want to confuse and be talking about, going all the way over to here and these lengths. So I'm just really focused on this angle, and I'm going to deal with, force that's going to be happening here. So we can ultimately figure out what this force would be on this member right here. And that's ultimately what we want to find, because we have a blank spot to fill in. So we could look at it over here. We could also take this and bring this up, just to line things up a little bit better. Oops, I should have kept that way. So we can deal with, in this direction, that if we deal with that, we deal with that in a 90-degree angle there. We're going to be ultimately trying to look at what this force is here. If we label this A, and our point D is going to be somewhere up here, we're going to be looking for a D. We want to find what that is. That ultimately is what we really are trying to find out of this. We have a segment A, B. We will need to know what that is. We have, if we look at this, we're going to have, this is AD. We can break this up into the parts, and we've dealt with that a little bit before. We can deal with AD, this AD in the Y direction. So we're looking at that right there. Kind of bunching things up too much. And we can also deal with this. So this component of this force would be AD in the X direction. So we would want that. We know we have a reaction force at A in the Y direction. And that was, we already worked with that earlier. We said that was right up here, 975. And so are there any other forces that we're going to be looking at dealing with? So we ultimately want AD. We're going to need to figure out what AD is. And we're going to need to figure out what ADY is. So what are we going to be dealing with here? So we're going to use, once again, we're going to go back and say some of our forces in the Y direction should equal 0. And so we want to deal with that again, so let's look at it this way. So some of the forces in the Y direction are the up and the downs. So what do we have in our up direction? We have up direction, we have R y direction was 975. So we have to have a down. So it fits that this should be the down. So we're going to have a down of AD in the y direction, that component. And one of the things that we look at is if this is 45, this also has to be 45. And we dealt with that just by looking at this being 90. Also here, 45, 45, this has to be a 45 degree angle right there. So at that point, we can do a couple of different things. Let's stick with this for a minute. So we know that this side is 975. I don't see anything else in the up or the down direction. It's just this force, so that has to mean that this has to balance it. So we have to have 975 on this side as well. So ADY has to be 975. If you want to keep track of it, it's a negative, it's in the down direction, so we could put a negative on that, but we're going to leave it as that for right now. Okay. So what we could look at is this ADX. If we looked at this, we know this side now is 975. We know this is a 45 degree angle. This is 90. This has to be 45. So if you're dealing in terms of remembering your trig functions, remembering your geometry, if this is a 45 and 45, that means this length and this length should be the same. So we know that this side really should be also be 975. And that is fine for us to deal with. Now, that's 975. Which direction are our forces? Which direction are we dealing with those forces? Well, if we're dealing with this being a reaction force, we said this reaction force was over here was 0. What are we going to deal with? We need to deal with our forces in the x direction. Should be equal to 0. So we need a force in the left, force in the right. So this AB should be in the right direction. AB, we're going to go ahead and put that there. And this ADX should be, we're dealing with in this direction. How do we know that? If you look at this, if this force is pointing down and we need an overall force, if this is pointing, this force here, ADY, is pointing in the down direction. If we were to say this force is pushing in the opposite direction, that would have to make this going up. So if this is going down, that kind of forces us, when we're going down, force us to also be going in the left direction. So that's why ADX ends up there. So if we look at this, we still end up having to balance them out, 975, which means our AB has to be also 975. So what do we have left? Now we just have our hypotenuse of our 975, 975 triangle, which is a right triangle. So we can use Pythagorean Theorem to solve that. So we need to find what our c squared was. So we're going to have to do the square root of that. So ultimately our c is going to be equal to 975 squared plus 975 squared, and that should give us what c is. In this case, c is equal to, I should have just left a d rather than calling it our, so now that should give us what that answer is. And if we calculated that, I could put in the calculator for you, but we end up with 1379. So 1379 is what we end up with. Okay. Okay, so our next step, we're going to move across. We could put these in now. We know what AD is, so it's 1379. We know it is in which direction we're dealing with and which direction that is in. So we put that into our overall force. So in this case, it shows it should be in compression because it is in the, it's dealing with in the down direction on both of these. So we are in compression. That's where, in this case, unfortunately, that's where it doesn't necessarily give us a lot of good details as far as negative. We look at this one and we're like, AD in the X direction, okay, that would have been negative. When we square these, the negative is going to be gone off from those. So this is where the logic comes in and having to deal with, if we know this is down and this is to the left, we know that this has to be going this way, which means it has to be negative, which gives us the compression. Okay, so let's move on to our opposite side, ECB. So we're going to come over here to ECB, the other side. Do a similar thing to what we just did with that side. Things out of the road. So let's pull this down. Figure out what all we're going to need off from this. A would be up here. B would be here. So what are we going to need? We're ultimately going to be looking for CE. We're also going to have a reaction force in the Y direction. We already know what that is. We know that was 775, so we can go ahead and put that down there. So what are we going to be dealing with now? We also know that this was a 45. If we go ahead and make our little mock triangle here to help us kind of keep track of things, we know that this would also be a 45-degree angle. What do we want to find? Well, we want to find CE in the X direction. We want to find CE so we're ultimately dealing with this. So we want to find the component of CE in the Y direction. And we want to come out here and say, what is this force here? So that being BC. Okay, so let's do our forces. So some of our forces in the Y direction should equal 0. So if we did our table, we end up with our up and our down. So what do we have in the up direction? We have RCY. What do we have in the down direction? We know that this component must be down. So if that component has to be, that is going to have to be down as well, which means this is also going to have to be to the right on this one. So what do we end up having? RCY, what's going to be the component against that? We're going to have CE in the Y direction, going to be going down. So this was 775. Do we have any others, up or down? Just those. So 775. And so that means this side has to be 775. And so that means CE in the Y direction has to be 775. So we can put that in. Now, we remember 45. This is also going to be a 45 because that's a 90. So we now know that also CE in the X direction also has to equal 775. And now we can solve for some of our forces in the x direction equal to 0. So if we do that, we've got our x equal left, negative, right, positive. So what forces do we have in the x direction? So we have this one that's going to the right. We have this one that's going to the left. So BC, why put BE, sorry. And so if we total those up, I don't see any others in the x direction, 775. So that means this has to be 775, which means BC has to be 775. So we can fill that in 775. Okay. Now, once again, what do we have left? We have our hypotenuse, which is this part of the triangle right. We're doing right here, so we have a side, so we got 775, 775, and we're looking for the hypotenuse. So yet again, we can figure out that CE squared, so we're going to square root that, equals square root of 775 squared plus 775 squared should equal CE. And that should equal, calculated that out, should equal 1,096 pound force. So 1,096. Okay. So we can go back and put that into our diagram. 1,096. Oh, we can put these back in as well. So we can put these down. 775. And pull our other one to make sure I pull it correctly. 975. 975. And then we do a quick check to think about what that's going to be set up as, how we're going to tension or compression. This one's still going down. And I'm also perfectly fine with you checking these on our simulation software. So going ahead and going into the software and simulating what's going to be happening with these. These are going to be in tension. It's pulling out here, it's pulling them, it's pushing here, it's pulling. So there's where some of the logic comes in and keeping up with what's going on here. So it's going to be pulling those. And we'll go to the end and we'll show it on simulation, put everything in the simulation and see what it shows as well, just to double check ourselves. And I'm going to pause there to get another segment. Okay, so I'm going to continue. I went ahead and I'm going to start on a new page for each one of these. So we're going to work through, and at this point we're going to work through the little step right here. We're going to work through our forces mainly over here. So we're still going to utilize what we were doing over on this section. So we're going to have to go back and pull some numbers back out for like our ADX, so our X component of this, and our Y component of this to help us solve across and work our way across. So let's draw that out for what we're actually going to be working with. So we're going to be working with something that looks more like this. We're going to remember that we have our 1,000 pounds of force coming down here. We're going to be dealing now across this way with our force. So we need to remember what we had going on here. We're going to need to utilize that. So we had AD in the X direction was 975. We had this section right here, AD, the Y direction was 975. And so we also have to think about this a little bit. When we wrote this before, we wrote it was in compression. So we dealt with that, this as being in compression. So what does that mean? It means compression here, it means compression here. So basically at our joint. So when we look at this, we have to think about this arrow is going this way. So at this side, when we're dealing with this setup up here, we're going to be going towards the up and the right direction. So we're going to need a force going this way, and we're also going to need a force going up over here. So these forces at this point are going to be going like this, going like this. So we know our force is going to be going like this. And if I could draw on my, there we go. So just kind of help us keep track of things a little bit in which direction our forces are going. So we also know that AD, we already solved for that. That was this piece right here. That was 1379. So we're going to keep track of that. So what we're really looking at now is we're going to be looking at, this was D. So we're going to be looking at D, E. What was it? That's really what we're trying to find. So we're going to take this out and make another right triangle out of this one. And we're going to be dealing with what is so BD, this was our point B down here. So what is BD? That's ultimately what we're trying to figure out as well. So we need DE, we need BD. So what are we going to be dealing with right here? We're going to be dealing with this as BD in the Y direction. We're going to be dealing with right up here, this is BD in the X direction. So we're going to need those. And so now we need to look at what were our angles that we're dealing with. What angles did we have? So we need to look and say, do we have those angles? So we have 56.31. So we need to figure out if this was 56.31 down here, what is this angle right here? So if we did, this is a 90 degree right here, we need to take 90 minus the 56.31. So that will give us what that angle is. So we're going to do 90 minus 56.31. So that's going to give us 33.69. Okay. So is what's going to give us for that angle. If we wanted to keep track of that, we could go ahead and put that in here. So we've got that inside of there. So at that point, we need to deal with, we know we have, what do we have? What information do we already have? Well, we are going to have to find some more information. So let's work with finding that, and then we'll work our way farther. So let's see what we have available. We have, let's see if we can deal with some of our forces in the, in the Y direction. So we have our ups, we have our downs. What do we have in the up direction? We need to deal with A, D, Y. That's going to be our up. What do we have in the down direction? Well, we know that this is down. We know that we're going to have to be dealing with that over here. We're going to have to be dealing with that down in our down direction over here. So we know we have a down load of, oh, we have that's 975. Okay. We have a down of 1,000, so that was up. This is our down force here. So we've got to figure out what is this one going to be. So we need to figure out BDY. So that should also. So if we look at this, if you want to do, you can look at things like this first. Say we're at 1,000 right here. We're only 975 over here. So we have to have something else in the up direction. we have a force here, there's our vertical and a y direction, there's a y direction, there's a y direction. That's all we have is these three. So that means that the BDY has to be in the up direction. So we know now where it has to go. So to have in the up direction, 1,000 minus 975 must give us our 25. So now we have that, so we can put in BDY equals 25. At that point, what we can work with is we can solve to figure out what this side should be. Realize this is not a 45, so it's not quite as easy to just say, hey, that's what's going to be over there. So at this point, we need to do a tangent of 33.69. So it's going to be equal to our opposite, which is what we're trying to find, over our 25. So if we now multiply both sides by 25, we end up with our opposite will equal 25 times the tangent of 33.69. So we put that into our calculator and we end up with our opposite side, which our opposite side is going to be BDX equals 25 tangent of 33.69 equals, and that comes out to be 16.67. So now that's 16.67. Fill that in. Now we can use Pythagorean Theorem to figure out what our other side is going to be. So we're trying to find BD. So BD squared, square root of that, is going to equal the square root of our two sides, 16.67 squared plus 25 squared. And if we solve that, we should come out with 30.1. So that's going to be, here is going to be 30.1. Okay, so we've got a 30.1. Okay, so now at that point we need to go back and figure out what our x components are. We've got our y components. We filled in everything except for our DE. We need to figure out what DE is going to be equal to. So what do we need to do at this point? We need to do the sum of our forces, and the x direction should equal to 0. So we're going to do our little table. And so we end up with our lefts, we end up with our rights, and what do we have? We have, what do we have in the right direction? A dx. So we got to look at what do we have. We have this piece, we have this piece, and we have this piece. So this is in the right direction, in the right, so it's 975. And that was a dx. We have, what do we have in our left direction? And if we look at this, if we're looking at what's going on here with this one, we are going to have this set up like this. So this is going to have to be doing something like that. So that means that BDX is going to have to be over here. 16.67. So at that point, what we know is we have 975 over here. We need to have 975 over here. And we're missing a force. So at that point, that means DE must be the force that we're missing. So we're going to take our 16.67, subtract off from our 975. I go back through this again, okay, since I slid my page down. So sum of our force in the x direction have to equal 0. We have our right direction, 975 ADX, so we're getting that from right here. So we knew that's going to the right. We know that this force should be going up, and so that means this has to be also going to the left. So that's going to have to be, put our 16.67 on the left side. If we bring this down, our 975, we have 970, knows we need to have 975 on this side. Look at the number of forces, 1, 2, that's our third force. So now which way should DE be going? In this case, DE needs to be going to the left because we're not at 75. So we've got to subtract 975 minus the 16.67, and we end up with, I believe, 958.3. Should check these numbers in front of us. So 958.3, and that's in the left direction. So it's left. So we've got those forces there. So we can go back and we can fill those in on our diagram. So we're looking for BD, 30.1. We're looking for DE, 958.3. And at that point, we need to double check and make sure that we're getting those. What are we having? This force was going to be this way. So we're going to say that was going to be in compression. And at this point, this is also going to have forces pulling. Doing that, so we're going to end up with, make sure I put these right. Compression. So now we're looking for our one force that we've got left over here. So we got to figure out what's going on with it. So we're going to work into that one. Okay, so let's go into the next step. Next step, find that missing force. Okay, so we're going to move over to the other side. So we're going to be working our way over. Make sure I can keep this on the screen this time. So what are we going to be dealing with now? We're going to be dealing with this. Triangle set here. What do we need? So we're going to be looking at, we looked at DE earlier. So we got that. We came up with 958.3. We have already found this information from over here. But we should have drawn that a little bigger. So we end up with CEX, we found earlier, was 775. CEY was 775. We also found CE, which was 1096. So what are we going to be looking for at this point? We're going to be looking for BE is what we really want. So we're going to be looking here. Jumped on that arrow a little bit soon. Let's come across. Done this one too many times. So we're going to be looking for our portions. So we're going to be looking for BEX up here. What is that going to be? We're going to be looking for BEY right here. And we did DE, so we need to figure out what we're working with and where we're working with things. Okay. So yet again, we know that this, if we bring this down, no matter where we bring this down at, we have a 45-degree angle here. We have a 90 here, so that means we have 45 there. So we have to, oops, I did that wrong. Wrong angle, right? 45 was over on this angle over here. Was over in this area, right up here. So we don't, sorry about that, we don't want to confuse that. Okay. But we do know from our angles earlier, if we look back, we know from our angles earlier that we still have we have an angle of 56.31 for this angle right up here. So this angle right here should be 56.31. So we can look back at that and we can deal with that. Which means that we need to figure out, we're going to want to look at and see what is this angle right here. So that angle right there should be, if we subtract that from 90, should be 33.69. If we look back, we did something very similar. We just did that, just work with the same thing. So we're working with similar setup as far as our angles go. Okay, so now we have, at that point, we have our angle 56.31 here. We are looking to solve this side, and we're looking to solve this side. So we need to deal with, let's go back and look and see if what we've got as far as our forces go. Some of our forces in the y direction, excuse me, we have our ups, we have our downs, we have CE in the x direction. We're not dealing with x yet. We have CE in the y direction, C in the y direction. So that we're saying is going up. CE, the y, that was in the up direction, so it's 70-75. Okay, so we've got an up. We've got a force. The force on this one, I'm left off the force. A force of 500. So we've got a force at E. Of 500. So if we look at these, what other forces do we have? We have one more. We have this, and we have this. We have 3. Ignore this, sorry, dotted line here. That was doing the same thing as what we're doing over here. We're just showing that pulled over here. We're going to show it over here rather than dealing with it on this side. Okay, so that was just to help us get the 56.31. So at this point, if we look at this, we've got 775 on this side, and we've only got 500 so far on this side. So that means we know we need to have 775 over here. So if we took 500 from 775, we know that we have to have another force that's 275 over here. The only thing we have left is the BEY. So that's what BEY has to be. So that's going to be 275. Okay. If we want to find out what is, so we're going to look and see what can we do with BEX. Let's go ahead and see if we can work with that. Sum of our forces in the x direction should equal 0. So we have our lefts and our rights. What do we have? So we know we have DE. DE is going to be off to the right. So it's 958.3. What do we have to the left? We have CEX. X component of CE, 775. I don't know why I drew a line there. And so if you look at this, once again, we end up with 958.3. Kind of skipping steps, sorry about that. We have an X direction there, X direction there, X direction there. So we have 3. We have 2 of our forces. If this is 958.3, we 775. We know we need another one over here to get up to our 958.3. So what do we have over here that we need to deal with? We need to deal with BE in the X direction. So what's that going to equal? So it's going to equal our 958.3 minus 775. So that's going to end up giving us 183.3. Okay, 183.3. So we've got that. Now at that point, we can figure out what our hypotenuse here would be for this triangle. So that will give us BE. So BE, once again, square root of that equals square root of 183 squared plus 275 squared, and that gives us, if we calculate that, solve that out, should give us 330.5 pounds of force. So there we go, 330.5. And so if we go back and fill the rest of these in, we've got one more to fill in right here. And what do we want to do with that one? What's going to happen with that one? Tension or compression? And it is going to be it's pulling this way, pulling down away from that joint. So it's actually going to be still in tension. Okay, so that should solve everything that we needed in our triangle, and that should finish us up. So I'm going to pull up a simulation for the last little bit and walk through the simulation, but we're going to stop there, and hopefully I didn't cover anything up on the page. Okay. Okay, so we're going to work now on doing the simulation using the SkySieve. So SkySieve.com, free Truss calculator, and just a reminder, on the free version it only allows like 3 times per day. So make sure that you're ready to test when you actually hit the test. So we're going to need to set out and do our nodes. Now the downside is, remember on this one you have to set up and realize what your X and Y positions are to begin with. So we need to have a pretty good idea of where we're going to be putting everything, so that we don't end up with things in weird spots or in bad spots when we're working on that. So we're going to start off with a 0, 0 position. So we're going to do that as our point A. So we're going to go ahead and put that in there. I don't know if it'll let me, I don't think it'll let me choose that. So I'm going to do just point 1 as the 0, 0. I'm going to go ahead and do I'm just going to do them in letter order, so A, B, C, D, 1, 2, 3, such. So point 2 is going to be B. So I'm going to say that's still going to be my point in the X position is just going to slide over. My Y is still going to stay 0. So it's going to slide over and be at my position 5. So I need to put in 5, and then I'm going to go ahead and say apply. So there's my point 2. Now I'm going to go ahead and put in C as my point 3. So it's still going to be a 0 for the Y position, and it's going to be over 10. So we need to go over 10. So we're going to put in 10, say apply. So now notice it did slide everything together a little bit more now. So now we need to go put in D, point to D. So D is going to be at 3 in the X position. And in the Y position, we also went up 3. So that's where it's going to be. So we're going to apply that. And then we need to put in E. So E was also going to be, in the X position, it's going to be across, going to be 3 plus 2 plus 2. So we're going to be over 7. And in our Y position, we're going to be up 3. So it's still 3 high. So you're going to say apply. Now, we've got that. So we're going to go back, and we're going to add our members. So at this point, we need to add in our members. So we should be able to click on them and drag to our next position. So we're going to need a member there. We're going to need a member across to here. get a little more study on this to get this one. Okay, we need a member from 1 to 4. I need to pause this and draw it off screen. Okay, it appears we were able to get that. So now we're going to say, we're going to go back with that. And we need to add our supports. So we want a pin. And we're going to add that at node 1. Apply that. We want to add a roller, and we're going to add that at node 3. And so now we should be good with those. So let's go now to, okay, let's try applying these forces. So we're going to do point loads. Make sure that you have double checked to make sure all your settings are set up in feet in the imperial system. Feet, PSI, pounds, all the way down this list, and save that so that it stays set up correctly. If you open this and you have it on a new computer or something, they're probably not going to be set up. So make sure you double check that before you start. So point loads. So we're going to choose from from node 4, and we're going to choose that we're going to do Y because we're going to go in the Y direction. Now remember, this is a down, so we need to make sure that we do 1,000 pounds force in the down direction. So we're going to say apply. And now we're also going to choose, a point 2, which is going to be our B location. So we're going to choose node 2. No X direction magnitude, Y direction magnitude was 250. Make sure that you remember the negative 250 because it's in the down direction. Hit apply. We're going to choose node 3. Also notice that these, not 3, I don't want 3. I want node 5. So notice also that the size of these is changed based upon, so these vectors, 250 pounds, see how small that is actually based upon the size of magnitude of your vector. So 500 for E, so we should see something about half the length of what this 1,000 one is. So we say, yep, make sure that we remember the negative. It's much easier to do that from the beginning than it is to go back and edit these. So there is that. So now, notice there are no negative signs. It just shows the direction that they're pointing. So those are all of our forces that we needed. So we can go back to this, make sure you've done this, got everything set up, that it's good to go, because you get 3 shots per day. So we're going to go ahead and have it do the solving. It says it's solved, so we're going to say OK and check it out. So we want to look at our reaction forces. 975 and 775. So if we come back and look at our calculations, hopefully those come out correctly. If we go all the way back to about step 4, we've got 775 that I'm seeing there calculated, and if we come off to the other side, we end up with 975. So those so good, so far so good. If we come off to our moments, it's an upgrade function. I forgot about that, so we can't double check those. But we can go to our axial forces, and so now we can go through and we can check all of our numbers. I'm looking, we had 1379 over here, so we just rounded, and they do not have theirs rounded. 975 here. Also notice we had chosen Double look at what they've got here. Notice these two arrows are pointing at each other, which is different than what we're saying for compression. But if you look at it as a C off to the side, so it is compression. We did designate ours also as compression, just they use a different designation for the arrows. Also notice compression is in red and tension is in blue. So if we look at all of ours, it looks like we had 30.1 here, so similar. 958.3 here, very close. 330.5 here, very close. And so far we've got everything tension and compression correct. 1096, 775, and so we do look to be that we have solved things correctly. This is always a good thing whenever this backs us up. Hopefully that helps out. Let me know if you have any questions.